Welcome to this special edition of the New Stack Makers on the road from MongoDB World 2022 and New York City. Discussions from the show floor with technologists giving you their expertise and insights to help you with your everyday work. Headquartered in New York, MongoDB is the leading modern general-purpose database platform designed to unleash the power of software and data for developers and the applications they build.
Hey, it's Alex Williams back at MongoDB World in New York City, and I am here with Kenneth White, who is a security principal at MongoDB. How are you?
I'm good. Thanks. Thanks for having me.
Well, I am really curious on this topic, and I just kind of made the connection about this intersection of software development and cryptography. And that has, as I understand, been very difficult to understand and implement for developers. I expect for academics who build these types of cryptographic environments and are thinking about that intersection, it's different. And you've introduced queryable encryption. Perhaps you could talk about queryable encryption, what it is, and how it reflects that intersection of software development and cryptography.
Sure, absolutely. Well, I should probably take a step back and sort of explain some of the clients and customers we have that have been looking for it. So, one of the things about Mongo is I think a lot of people know us from, our work with, startups and with sort of, newer generation companies. I don't think there's quite an appreciation how much of the enterprise we power. So, our Atlas platform, the managed database as a service, it backs entire European pension systems, currency networks, treasury systems, payment networks, retail and investment banks. If you're doing credit card transactions with major pizza chains or pharmacies, there's a pretty good chance you're running through Mongo. So, these are, some of these systems are, billions of dollars of flow. And so they're, these are the most security sensitive kind of workloads there are. And so customers have, they're always asking for sort of better security assurances. But one of the things that they've said is, look, we're not, our developers aren't cryptographers. We can only do so much security training. And frankly, they shouldn't have to make hard choices. They shouldn't have to have them make decisions about, this encryption mode or that encryption mode. It should just like work. And to some extent, like the software world has done a pretty good job. Like language frameworks have gotten better. They still give you like a kind of a whole toolkit of things if you want to, chop and dice and build your own. But for sort of like the typical Python developer, the typical Node developer, someone working with C#, they just want to, be able to call a function, say encrypt this, and then I'm done with it. I don't have to think about it. And that's our view as well. So we started the project, the foundations of it were probably 4 years ago with our client-side encryption, which is a type of end-to-end encryption. So if you need to store, say, a social security number or a credit card, you can use the technology we've got. But one of the big pieces of feedback we got was, it'd be really nice if we could actually query against it. So, like the last 4 digits of a social security number, the last 4 of your card number. I'm a customer service rep, and I need to, someone is telling me their name over the phone, and I just want to type in the first few letters of their name, and then, have the system pull up the rest. Being able to search from like prefixes and suffixes, substrings, the kind of things you think about that databases are supposed to do. But we want to do that on encrypted data. And our answer until recently was, well, there's not really a lot of options for that. But it's not a Mongo problem. It's a sort of industry problem. It's not a solved problem. And so what we did with queryable encryption is we worked with some folks that have been collaborating with us for a while, and they made some breakthroughs. And about a year and a half ago, we acquired them. And so that crypto team is now in-house. We've got a whole advanced crypto research group with, I think, 7 PhD cryptographers. And so yesterday we announced we're rolling out for a preview the queryable encryption, which lets you, for the first time in any database, search on fully encrypted data in really expressive ways. So super excited about it.
How does that affect the way that data environments are developed initially. How will that affect the industry?
Well, we're hoping, one of the things that we believe in is in open standards and open cryptography. I mean, one of the things I think in general about security is people want to understand your systems. They want to be able to analyze them. They want to be able to, to hack them. Frankly, they want to be able to do analysis against it. And so, we don't believe in black box crypto or proprietary sort of things. And so, but particularly in the cryptography world, proprietary systems are like, you know, kind of like high voltage rail or whatever. So in existing systems, most developers think about TLS, they think about network encryption, they think about like storage on disk, and those are important, but they don't really get to things like when the database is actually running, right? Like, so if you have a DBA who's got high level administrator access, maybe they need to run patches or security updates or things like that. But do they really need to be able to see, like in an employee HR system, everyone's social security number or their pay stubs or their bank accounts? And so, being able to sort of separate those two things is really important. And then when you move a workload, when you're a big bank or big insurance company, you move a workload to the cloud, you're really thinking about, what are my institutional risks from a third party, right? Because I'm handing this incredibly sensitive customer data over. I want better assurances that, that it's not going to be compromised either through negligence or through some malicious inside attack. And so it's not just a theoretical concern. I mean, we have customers, as I said, that are doing billions of dollars in transactions on the platform. And so, they really do have to think about those levels of threat. But more broadly, people just want better privacy and security controls. So, we think this is going to open up a ton of new use cases for us.
Tell me then about the process that you went through to make this a academic capability and more of a developer capability. Tell me about the algorithm development and how you had to think about that with the overall architecture of MongoDB technologies, Atlas, for example.
Sure. Yeah, I mean, I think if someone were from, like another planet and they read all the academic cryptography literature, they think, well, you've got countless choices and things. Of course, you should be using this. But if you dig a little deeper, there's a lot of assumptions and a lot of missing constraints. So, like, this particular encryption technique has been evolving for 15 plus years. It's not new in the sense of, the research community. What's different, though, is when you take sort of a toy project or a toy example, if it's easy to have sort of one laptop and one database server and make a sort of a demo system with a few hundred records. Now, when you scale that to hundreds of millions of records across lots of different databases and lots of app servers or web servers, that's where things break down. Because what you don't want to do is you don't have to go to a developer and say, it's already hard enough to write a secure website, like a basic web application, but we're also going to make you have to manage state across all these different applications. It should just work. If I'm a developer and I just want to say, DB users find this social security number, I should be able to write that. And that's what we've been able to do. So, the technology is really cool. It lets developers think and express the way that they're used to. But in terms of how we got here, the biggest breakthroughs weren't cryptography. They were like the engineering pieces. They were the things that make it so that you can scale, so that you can do key management, so that you can do indexes that really that have these kind of capabilities in a practical way. So not in a toy system, because our customers, these are monster workloads. These are really sizable workloads. We've got some customers that have over 800 shards, meaning 800 different physical servers around the world for one system. I mean, that's massive. Now, obviously, not everyone has that kind of concern, but you need to be able to go from a simple kind of proof of concept system or a sandbox or some small system to the biggest. And so it was a lot of the engineering, just sort of the hard grind of engineering over the last year and a half to sort of translate those math and algorithm techniques into something that's practical in the database.
So translating those that math and algorithm information into these very large systems.
Exactly.
Right.
I mean, a lot of the academic papers start with, assume you can create a database from scratch and rebuild, the engine. It's like, Really? I mean, our core engine is 10 years old. I mean, you look at any other major database, like this is really mature technology. You don't just scrap that for a security benefit. Like, I mean, maybe somebody will, but then you lose all the other things. You lose transactions, you lose clusters, you lose all the identity and two-factor authentication and all the authentication, like all those really hard things that make up a rich database. You can't just toss that out. But a lot of the academic literature sort of assumed that you could do that. So the big thing for us was not having to make those massive changes to the engine and being able to do things on the application side where it still felt pretty easy for the developer.
What did you do on the application side then?
Right. So one of the things that we did is you have to understand that Mongo runs everywhere, right? So we have we run on embedded systems, we run on ARM, on mobile processors, we run on the Intel, we even run on IBM Z series mainframes. We have some customers that are bridging the mainframe world into the cloud, and then every operating system. So Debian, Ubuntu, Red Hat, Windows, Mac, every flavor you can imagine. And then on top of that, every language you can imagine. So Python, Java, C#, Node, Scala, all these things, PHP. Building in the capability for like a core crypto library that all those other languages could use, that's where a lot of the work went. And then also to sort of, making some of these translations happen so that you don't have to think as a developer, I have to rewrite all my query code, I have to rewrite all my application code. Like to us, the most important thing was to make it easy and give developers, simple tools without having to make complicated choices.
And that requires a lot of listening. Tell me about the team that did that. Tell me about the people who are on that team.
Yeah, and in one of our presentations, one of my final slides is it's labeled "It Takes a Village," and I think there's like 45 engineers listed. We had 14 different engineering teams over the last several years working on this. So if you think about a database company, you've got specialized teams that all they do is focus on performance. Another team that all they do is focus on how to make queries, work in a proper way. We've got teams that just work on Java, that just work on Python. We've got other teams that just work on like key management or kind of the identity piece. So all of those different groups had to work together. I mean, it was a huge sort of orchestration of of different groups and teams and things. But yeah, it's been fantastic to work with them because actually some of the biggest work we did was with their documentation team. We have a team of probably 6 or 7 people just dedicated to this one feature. They've been working for 3 months tirelessly. And so yesterday somebody pressed a button and now it's all public. Right? So all that hard work is there. So developers can say, look, I don't know where to start. Like I literally want copy and paste like a hello world, like I've just installed Go or I've just installed Python or Java. I just want to like get to step one. And so they made that really easy. And it's a lot of work to do that. And I think documentation, good tutorials and things like this, I think they're really underrated in this, in our world.
Documentation and tutorials, are foundation practices that not everybody does. What were some of the other major challenges that came with this, with these teams? What were the challenges of integrating this technology into the projects that they were building across those many teams that you worked with?
Well, I mean, I should say too that this was a board level strategic priority. So when we did the acquisition of Aroki Systems to bring in the IP and to bring in the principles, that was just sort of like the first step in a major investment. And so, you can imagine any engineering org, you're always juggling, dozens of different projects and requests from customers. I mean, we've got people in every kind of business you can imagine that have all kinds of, crazy asks. And so just sort of balancing that was where it got, a little interesting. But you do that. So, we work on the languages, we work on the docs, we work on the integration, just lots of different moving parts. And so the people management was probably half the battle, honestly.
So how do you think about distributing that across, in a distributed, I think about the distributed architecture of something like this. You have all kinds of customers who are working across multiple regions. For instance, I may be using AWS, right? You know, how do you think about, you know, pick one thing in particular, you know, the synchronization, for instance?
No, that's a good question. One of the things that customers bring up a lot is they really don't want to get locked into a particular platform. They don't want to be locked into one cloud provider or another. And we see this all the time. There's a lot of like corporate investment in one of the public clouds where maybe like central IT is sort of all in, but then a lot of the application development happens on a different cloud, or like, you know, or you've got a application group that like really prefers one over the other. So we rolled out some technology that allows you to like move keys between the clouds, or if you want to move it from cloud back to on-prem. So you know, if you're in GCP and you've built a proof of concept or a stand-up, and then you want to potentially migrate that to Amazon or Azure, it shouldn't be painful. And in our case, it's literally a push button and then a single API call to sort of migrate your keys. That's kind of like a little in the weeds, but it's a real pain point for people. They don't want to be stuck on one platform, and most of the clouds, by design, once you have a key in their key management systems, you can't get it out. It's sort of within the confines of their hardware. And then we have some banking customers too that have dedicated hardware modules that hold their keys, and they need to be able to like move from there to the cloud and vice versa. So we built that tech in as well. But yeah, distributed systems are our blood. So whether you deploy a single server or you're launching lots across all the different clouds, the system works, and it's optimized for really high speed searches. So we've been doing tons of testing. Part of what we're doing with the rollout is, these are security critical kind of workloads for customers, and so we really wanted several months of feedback from customers saying, look, here's our use case, here's the way we're using it, here's the way we've tweaked it, here's our experience. Can you maybe take some rough edges off this, or can you help us with performance tuning on that, and so forth. So I don't think we're going to make any major changes during the the preview period, but we felt it was really important to kind of get that real world workload, because you can imagine a lot of banks and insurance companies and things, they don't want to share their data with us. So we can do benchmarks and things like that, but we don't really understand how customers are using, how their workloads look. So that kind of feedback is going to be critical.
So what's next then, beyond this launch of queryable encryption?
Well, so what we're announcing with 6.0 is the core crypto framework, and it's Apache license. It's open source. It's on GitHub now. We have equality matches now, so that on fully encrypted randomized data, you can do equality matches. We're rolling out range, and then over the next few months, we're rolling out the other sort of expressive query features. But it's a new platform to allow us to kind of build these other capabilities in. I mean, we have working prototypes for all these, but it's going to be a continuing evolution. And then the next thing is our Atlas Search product. So people want full text search, where like they're using Elasticsearch or Lucene or something like that. We have an Atlas Search product that's pretty similar to that. So if you want to do full rich text search, that's that's in view as well. And so it's something we're looking at over the next year or so.
Well, Kenneth, thank you so much for taking the time. I've really enjoyed our conversation here, and good luck with this work to really bring cryptography into the mainstream developer community.
It's good. I enjoyed it. Thanks.
If you like this video, please give us a thumbs up. And if you'd like to see more videos like this, you can always subscribe to our YouTube channel. We're on all the major social media platforms. You can always find us at thenewstack.io. We hope to see you soon.